we have seen the expansion of e to the power of x in terms of powers of x centered at x equal to 0. Yes. And we know that it is e to the power of x equal to 1 plus x square by 2 factorial by x cube by 3 factorial and so on. And this is an infinite series. Now, how do we arrive at such expansions? How do we, you know, come out with this given e to the power of x? Because once we have this, we know that if we end up with a series like this, that means it is equal to e to the power of x. But before that, let's look at what this means actually. So here, let's take the first term, right? So when we take the first term, what do we get? We get a straight line. Y is equal to 1. If we take the first two terms, we get this line. This is a tangent line to this curve e to the power of x at x equal to 0. Now, if we take first three terms, now to figure out how many terms we are taking, let me bring up this. And let me also display the expression that we are working with. So here we have taken up to 3 terms. So we have 1 plus x square by 2 factorial. And this gives us this parabola. And you might notice that as we increase the number of terms, it tends to start hugging the curve. So let's take it to the 4 terms, 5 terms, 6 terms, 7, 8, 9, 10, 11, 12, and so on. Now I have taken it up to 26 terms. And each time what is happening, it is converging towards f of x, this series, which means that as I take it to infinity, this series, it will become equal to e to the power of x. Now let's look at another function. Now this function is natural log of x, and we know that the expansion of this is natural of x equal to x minus 1 minus x minus 1 square by 2 plus x minus 1 cube by 3 and so on. And here the signs are alternating. You have plus, minus, and so on. And this is centered at x equal to 1 since natural log of 0 is not defined. Okay, so let's see how it looks like. If we take the first term, then we get this straight line. Since natural log of 1 is 0. Now let's take the first two terms. Nothing. Now let's take the first 3 terms, 4 terms, 5 terms, 6, 7, 8, 9, 10, 11. Beyond certain number of terms, nothing great is happening. So it stops converging with the function, natural log of x. So let's figure out at what point does it stop converging. So we have 6, 7. After 7, you will notice that nothing happens. So it stops converging after 7 terms. So which means what? That this would remain an approximation beyond a certain values of x. We can't even say approximation. It goes crazy. So that it is nowhere near the function. So what that means is that as we took this to infinity, it stops converging after 7 terms. Whereas in case of e to the power of x, as we took it to infinity, it converges entirely with the function. So the convergence is restricted to a circle around a point, The radius of this circle is called the radius of convergence. Once we know the radius of convergence and the center of this circle, we should be able to work out the interval of convergence. And interval of convergence can be minus infinity to infinity. That means it is going to be converging with the function in totality, or it could be restricted. In case of natural log of x, it is restricted. Whereas in case of e to the power of x, it was minus infinity to infinity. So what about in case of natural log of x? What is the interval? So let's draw this circle. So the interval of convergence is this circle of radius 1. So the interval of convergence is 0 to 2, where 0 is not included because natural log of 0 is undefined and 2 is included. So again, my original question, how do we arrive at such expansions? That we are going to look at in our next session. Now, again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.